Hello, today is February 6, 2024. It's a SIG Node weekly meeting. Welcome, everybody. Today on agenda, we have a few topics, and first is from Jonathan. I don't see anybody with this name on the call. Okay.
Maybe we come back to it because there are some cap-related topics.
Yeah. So next one is Philly. I can see you. Do you need or you just need it?
Okay. Can I share the screen?
Let me make you a co-host. Okay, you now can share screen.
Okay. Can you see my screen?
Yeah, thank you.
Okay. Okay, so I would like to discuss an update on the declarative non-maintenance cap since I was here last time. Just to recap, this cap is used for making declarative, like making the node maintenance more approachable for various workloads, because today some applications cannot deal with the disruption so easily. So like since last time, the non-maintenance objects now can select multiple nodes, and we have also decided to put stages into the non-maintenance, so we can go through idle, cordon, drain, or complete stage. And these stages are not reversible. So once you go to the next stage, you cannot go back. And I can first show you how this looks like in the flow. So first, like when you have some entity who wants to drain the node, for example, kubectl drain, we create the node maintenance, which is set on our desired stage, which is drain. And this will cause the node maintenance controller to pick up this node maintenance object, and it will make all the nodes unschedulable, which are set in the spec of the node maintenance. The kubectl drain waits for these pods to be made unschedulable. Then the node maintenance controller selects all the pods that should be evacuated from these nodes and will set evacuation request. And this is implemented as a condition. So each pod will receive this request to evacuate the node. And then this should be picked up by a controller. And if the controller sees the evacuation request, it should respond by setting evacuation initiated condition on the pod to say we accept it and we are evacuating from the node. To be backwards compatible, kubectl drain will observe this and wait for these pods to be accepted. And if they are not, it will fall back to the old behavior. So here, this is just for an example, we have a 3 minute long window. And if the pods are not accepted, the kubectl drain will follow up with normal eviction or deletion. So this is the first step of the pod controller. And so this is made like an extensible, so it can be used for any controller. Here we are starting with the deployment control that can implement such feature. And this can be used by applications to migrate or delete or somehow resolve the evacuation. So it should be application specific. But we can use, for example, deployment max search to do the evacuation for already existing workloads. So if we implement this feature in the deployment controller, we can look at our pods we have made, for which we have initiated the evacuation. And then we create search on another node, which is not evacuated. And once this pod becomes available, we can delete the pod on the targeted node. And here it's just a fallback to the old behavior by kubectl-drain. And it will filter out, like this, it has drain filters. It will go through them as well. But now it will also filter out the pods that has initiated evacuation, and it will not evict or delete these pods. So these pods actually can take a pretty long time to leave the node. So for example, they can do storage migration or state migration of the application, and it could take, for example, hours. And this does not have to be used only by kubectl-drain, but it can be used by other node drainers or autoscalers. And it can be also used manually. So like the one part of the API which I would like to discuss is the pod API. And like, so we are introducing like these two new conditions, which is evacuation request and evacuation initiated. So I would like to ask you if you think this is a good idea. Like basically, we need like three things. We need to make the request, make the initiation, and we would like to also see a progress of the evacuation, which is not possible now. So when the evacuation is initiated, we expect that the controller will handle the evacuation, and we do not check back. So this is one disadvantage of this approach, but I have looked like other approaches, and I'm not sure how feasible they are. So one approach would be, so we could have a probe on a pod, and it would monitor its evacuation or migration itself, and we could inspect this probe to see if it is proceeding. But this is a bit problematic because it has to be implemented by the application, and for example, cannot be used. The application has to know about the migration, so it cannot be used by outside controller to basically just evacuate the pods. For example, the deployment controller, it can just use max search, and the application does not even have to know that it is being evacuated. So, and like some other thing would be having some field on the pod, like where we could, for example, expect some timestamp to be generated by the controller. And if we do not see the update, for example, each minute, we would say that it is not progressing. So what are your thoughts about this?
I wonder on general status of this work. So you said that you working on kubectl-drain mode, but also said it can be used by autoscaler and can be used by other scenarios. Do you think it will be used by other scenarios, and is it the goal of this cap, or you just suggesting that kubectl-drain will be changed and all other scenarios may or may not be adjusted? Because I remember last time feedback was, can you analyze all other maintenance scenarios and understand if they will align with this approach?
So you mean you are asking about the users of the API?
Yes.
Yeah, so one thing is that there are multiple issues where people are experiencing problems with the drain, basically the administrators. and you can actually initiate this this manually. So once this is, so for example, we have these stages, and you can you can, for example, plan the maintenance. You create the maintenance objects. You tell your users that you are planning a maintenance. Then you make it unschedulable, and then when you drain, you will basically allow your users in your cluster to have some leeway for how long it will take them to leave the nodes. So I think mainly in the issues I have in the beginning of the KEB, like people could use these to solve their problems they are facing today. So you do not actually need some other like drainer or something. You can just post the API and it will solve your issues. And then you can use as a fallback, you can use the kubectl drain or some other like framework you are using.
I did invited some folks which have the real use cases want to control node upgrade or node the particular upgrade order for the node. Angela, are you here? Maybe you want to, if you
Yeah.
you can. Maybe you want to describe your use cases here.
Yeah. So our use case is that we are talking with the Portworx, and since a lot of our customers are running the stateful workloads using the Portworx, and one of the problem we are trying to resolve is that Portworx has the PDB restriction that it only allows one disruption at a time during the upgrade process. And if the cluster is having a lot, like a large size of many nodes, the upgrade could potentially be timed out, because that PDB basically restricts the upgrade process to be upgrade one node at a time, in order to improve this, and we have been discussing with Portworx to explore the potential options, and Portworx asked if they can define the upgrade order and specify the set of nodes that can be upgraded in parallel. In that way, the upgrade could be speed up, and yeah, so that's our use case, and just want to see if this KEB can potentially satisfy the request.
So you mean the main problem is the PDBs that are blocking it?
Yeah. So for Portworx, they need to maintain the quorum of the volumes, and so right now they just restrict the PDB to be like one disruption at a time. But if they can define the upgrade order and specify which set of nodes can be upgraded in parallel, the upgrade process can potentially be speed up.
Yeah, like when I was researching this, that's like one of the main issues is running into PDBs, that some applications do not want to be disrupted. For example, when you have storage and you want to keep your data safe. So we have also an example from KubeBird where they are blocking the upgrades because they are running sensitive VMs, virtual machines. So this is like one set of problems this is trying to solve.
My understanding it is it's just those stateful side or certain applications, even PDB can meet their requirement, but the problem it is because our upgrade is at the class level. We treat all the node the same, but even the node maybe have the different. So that's why the only way to make sure those applications not disruptive, so you end up have to do the sequential upgrade. So you end up have to take a much longer time for maintenance because you have no idea which small set, subset of the node might have some of the application and might need to be treated differently during this maintenance window. That's my understanding. I try to generalize the issue is just because the Angela shared the issue. It's just one of the issue I heard. They also have the other issue. They try to have the multiple rack and they try to control due to their application requirement. I don't remember detail, but it's just those. So the parallel is could be like the all excluded those special node using some of this kind of declarative way and upgrade them first. Then rest stuff you could just parallel and accelerate upgrade speed. Angela, did I summarize my understanding? Is match what you are saying?
Yeah, exactly. Yeah, thanks for summarizing this.
Yeah, so I think this should work. Like if you can identify which kind of nodes the applications can be running on, and so we could actually, and how much available you want them to be. So if you have, for example, some nodes with some devices that the applications need, you would select a subset of these nodes for maintenance and then do the upgrade in parallel. And so if you would be okay with the extra availability you have in the rest of the nodes.
Yeah, I had a question. I was just reading that bit about the PDBs, and if you have a PDB that's blocking like all evictions, then it stops the node from being like. I'm trying to figure out, like, isn't the PDB the problem in that case? Like, if your PDB says don't evict these pods for any reason, right? And then, like, now this would be another method to bypass the PDBs, but like they could already be bypassed if you just delete the pod anyway. The PDB only blocks eviction, not pod deletion. So I'm like, I guess I'm trying to figure out, is this trying to solve that problem? And if, like, I don't know, to me it seems like the PDB is like, that's just like a bad configuration. Like if you say don't evict my pods, then yeah, all right, they're not going to be evicted.
Yeah, so the PDB like was not designed with this scenario in mind, but we have seen like in the wild that people are using the PDBs to block the eviction completely. If they have like some sensitive data, they need to migrate before the eviction, and they are also doing that. They are also trying to cancel the eviction on admission. So it's not just the PDBs. So they are basically concerned about the safety of the data. And this is trying to solve it in a different way, that like the PDB and the eviction is like a top-down approach where you are saying to all of the pods on the node to get out like as quickly as you can. And this node maintenance is like a more proactive approach, that you are giving more power to the application. So the application can decide itself how it will migrate and how long it will take for the application to migrate. And so there is like a better communication channel between the administrator and the application owner.
This is Derek. Just a quick question. So I'm aware of many of our own users who would benefit from some signaling around node maintenance. And there are other like adjacent projects to Kubernetes like KubeVirt, where I know features like live migration of a VM across nodes is useful to get a signal. I haven't thought about this in great depth in a little while, because I think you know, in everyone's individual distributions, they've come up with different practices and patterns for this, I guess. But one of the things I'm wondering is the key need here is you need a signal to a controller that edits the PDBs to say, hey, I have pressure, or I want to do something. Please prepare to make your PDB not blocking anymore. One thing I wondered just now is if we had a way to signal into the pod via like a downward API process or some other domain rather than the API surface, would that be satisfiable?
I mean, it depends who you want to be the consumer. Like if it is the pod or the controller controlling the pod.
Yeah. So like one of the issues with like different approaches on node maintenance that I've seen is like it also can introduce another vector for security issues. And I don't know if this is a particular one or we talked about this previously, where an actor can basically request node maintenance on a node that they not be empowered to do. And
Yeah.
you know, have to be careful on those. But
yeah, so sorry to interrupt. Yeah, I remember this request from the last time, and I still have not resolved it, but I will be looking into it, for example, through the self-validation, if we can do something in that regard, but it's still in progress.
Traditionally, all these node maintenance controllers I've seen is that we have an API, then we run a daemon set on the node that listens to that resource for that API. And then we have no way of having a per node daemon set identity that says you can only do maintenance on this node, but not another. But assuming all of that was solved, I guess the only other thing I was thinking through is if your particular use case could be served by also just signaling into pods that this node desired maintenance, rather than signaling to the API server that the node desired maintenance. And maybe different sets of users could be satisfied by either domain, but I could see, you know, the kubelet having a mechanism that says, I want to do maintenance. Please, you know, prepare for that or be aware of it. Similar to how like graceful shutdown was handled.
Yeah, so the thing is, like, we would like to also, because if you signal just to the pod, and then you are only solving like a subset of use cases, and we would like this to be used also for existing workloads. For example, as I mentioned in the beginning of the CAP, like there are workloads that do not have PDB configured, but they would wish to have it. But so they have just one replica and do not want to run two replicas because it's, for example, expensive or the application does not support it, and would like to use, for example, the max search to migrate from one node to another, so they would not lose the availability. And the pod itself does not have to know anything about the maintenance, and the controller can just do it on their behalf.
Okay, I guess what I was just trying to think through is, so this is Derek. I work at Red Hat. I'm familiar with our own projects that have done this pattern, and I've also, like I said in prior discussions, been aware of where they've had downsides, also where they've had upsides. But what I was trying to think through is like, could some use cases you were exploring be satisfied with a downward API signal or not? And it was just basically a new thought to an old problem, and I was just curious what your initial reaction would be.
Yeah, I suppose some of the use cases could be solved by that.
First, I agree with Derek's security concern, and I also have other one. I want to raise one concern because this is from the application level, so all the application can generate this maintenance object, right? So to some extent, so how you are going to at the end you are aggregate all together. And if I'm the admin, and from my admin perspective, I'm not the application admin, I'm cluster admin. So from my perspective, I want to upgrade this kind of things, but all of the application admin maybe is the different people, different role. And they all claim, from their perspective, they claim of the generous maintenance, how we are going to aggregate and make sure this overall the cluster can be upgraded. So that's kind of things. And also if the different one maintain that to generate of the controversial order or all the requirement or rules, all those kind of things, how we are going to ensure those kind of things at the cluster level is unclear to me from this high level.
Okay, sorry, maybe I didn't catch everything, but so yeah, first thing, like the permissions issues has to be resolved first. The second is, yes, there are two personas. One is the cluster admin, and this will be probably used only by the admin and not the workloads themselves. They will just react to this change. And also we have explored other use case where this condition is, these are made generic. So it could be used, for example, by the scheduler to also deschedule workloads from a node under some circumstances.
So I guess
yeah.
in the spirit of like progress, I mean, I have experience, you know, operating environments where these types of solutions are available. I can see their benefit. I'm probably personally going to be distracted on the move forward or not until we just have the permission answer question. And once that question's answered, it's easier to make a safe decision. So can we try to get a resolution on the permissions question before going further on this, Kep? And just for those who weren't familiar, it was how to ensure any agent that might write to this CR can't impersonate other nodes. Like if root on one node should not allow me to drain another node is like a design constraint. And then how, as a cluster deployer, could I restrict this API such that certain classes of nodes or nodes with particular roles may never be subject to this API contract? That's kind of the two things in my experience that need to be ironed out. But is that a thing that we could maybe focus on as a next step then? Absent those two things, I think it's hard to be broadly used. And even in my own environment here, it's not a thing we make broad use of because of situations where those two security conflicts can be an issue.
Yeah, I think certainly we will have to resolve this. I will look into that as the next step. I just want to say that the API itself, we are trying to make it the least strong in the beginning. So it should be just like a suggestion to the application to move outside of the node. And we can then make the API stronger according to the needs in the future or extend the API. So, yeah. Yeah,
I mean, that makes sense. Any soft suggestion though it tends to be immediately followed. So like and if it's truly soft and then it's not really followed, then it's not always beneficial either, right? Either way, I just hopefully those two concerns would be clear, or you would share those. Like you'd want to make sure that root on a worker node in the cluster where some daemon set that's operating on this, or a kubelet that might be respecting the API, can't impersonate any other node. That seems fair, right? We would agree with that.
Yes.
Okay. All right, cool. So yeah, if we could just chase down maybe potential answers to that, it'd be more comforting.
Yeah, like to conclude just what I was saying before, like we will be like expecting like a gradual adoption. So for example, when you take the deployment, even if somebody would use this in a bad scenario, the controller will try to make not lose the availability of the application. So the application will always be available, although it will be on another node. And if it does not become available, it will not destroy the pod on the evacuated node. So it is soft, but the API might get stronger in the future. But yeah, for sure, we have to resolve the permission issues.
Yeah, and Mernol, I know, is also aware of like, pros and cons of exploring these types of paths. So I'm sure.
Yeah, I feel like, Derek, this comes up so much. Maybe it should be a part of the enhancement template itself. So whenever someone is writing or thinking about writing a KEP, which has components, they think through this. Oh, okay, I have to ensure this doesn't happen.
Yeah. So whatever agent is acting on this thing, I agree. Like if maybe that's a good point of like a KEP template. Like I approach these things as root on a node should not allow me to cause any impact on any other
Right.
node. And so just knowing how that's respected would want to be understood.
Okay. Yeah, if I can ask if just the general shape of the API seems okay to you, or if you see some other problems, for example, with the conditions, or if it can move in this direction.
Yeah, I mean, I know at Red Hat we have a node maintenance operator that's also in the open source. We could contrast that with this. That one probably has lessons and learnings along the way, but yeah, I don't know. Mernal, do you have that top of mind on if this looks much different?
I'll have to refresh. I know like Philip has a pointer to it, so
Yeah.
Okay, great. Yeah, also we have looked at the non-maintenance operator as well. But yeah, this is going in a different direction than the non-maintenance operator, which just does the old eviction on the admin's behalf. So this should be like the new approach for migrating the applications.
Awesome. So I think getting the security concerns addressed first, or enumerating those, would be the best next step.
Okay, thank you.
Okay, thank you, Philip. We're going to the next topic, and it's from Peter.
Hey, everyone. So I'm just checking in on folks' thoughts about the recursive read-only KEP. There was, we talked about it a couple of weeks ago, and there was a moment where we thought maybe going forward with just the containerd fix was the right direction, but then Tim Honkin said that wasn't acceptable. So it's kind of been revived, and now we're, so I just wanted to see what the SIG thought about the approach as it's outlined, and see sort of if we can make forward progress this release.
So I think one thing I would appreciate is like if folks could also take a look at it and think about the feature detection piece. So that's the one that is gonna probably be reused by the user NS KEP as well. So how we avoid situations where a pod is coming in and we don't know till we are trying to apply it in the runtime that it's gonna fail. So there's a proposal for runtime handler features. So the kubelet can potentially query if a particular feature like RRO in this case, or user NS is supported by the handler, and then fail and give a nice pod status versus the runtime trying something, failing, or just ignoring it entirely.
Yeah, exactly. And originally, sort of a feeling that I had about the recursive read-only KEP was that it overcomplicated doing that very thing. But the fact that we could reuse it for user NS, and like it seems like there's a desire for something like that, seems like it could be the right direction.
Yeah, my fear with any feature detection logic that may exist, especially for this RRO thing, we need to understand the expectations long term. In case of RRO, I think the expectation is that at some point we will just assume that it's present. We wouldn't check for it. But if feature detection is designed in such a way that we need to ask if it's enabled, then we can never get rid of it. So it will always there. So, I mean, maybe in this case, it may be some opposite check of sort. So it will, but yeah, I only to read the KEP to understand what the current proposal is.
I think there's also,
yeah, go ahead.
Oh, sorry. I think there's also something to be said, like it's in part a feature detection, but also in part like a graceful enablement of the feature. So I think that that a lot of what Tim wants of it is to have a way for a user to like opt into this change in the runtime that would otherwise be opaque to them. And I think for user namespaces, it could kind of function similarly. But I agree that having these features stay forever would kind of bloat, support matrix, configuration over time.
I think the main concern Tim had was that we don't break people.
Right.
Right. So, and personally, like given the specific feature, like there's the workloads are sort of broken if they're assuming the current behavior, but we just don't know. So, like an alternative in my mind is pre-flight checks or some sort of visibility tools to enable people to see that they're going to get an issue and fix their workloads, but that may not be general purpose for feature discovery. So I haven't looked closely at the CAP, but I'll take a look. I discussed it a little with Tim, so I'll take a look as well.
Cool. Thank you, John.
Thanks.
Duplications are always hard. Yeah. Okay.
So back to your original question, Peter, you said how we're going to pursue it, because I believe you are in mind of the 1.30. So since we have the concern and there's the concern and still at the debate, I think we just missed the 1.30. Is that okay for this release, for this feature?
Yeah, I guess I'm personally not as invested in it as Akihiro is. I think part of what I'm looking for is what Mrinal brought up is like the feature discovery piece of it and how that relates to user namespaces. That's where I'm personally more invested. But also just as a like good faith sort of supporting of a community member, having Akihiro not like kind of languish in like pre-alpha forever is the other thing that I'm invested in.
Yes.
So I'm fine if we sort of move forward to some degree, but also I personally want to figure out how this relates to user namespaces and if we can take pieces of this and like reuse them.
Okay.
For 130 specifically.
For 130?
So I think there's a discussion on the user namespace CAP about like doing something similar to the feature discovery that this read-only recursive read-only mount CAP wants. So, and my hope would be to push to beta in 130. So that's sort of where part of my investment is coming in here. For user namespaces, that is.
So are you suggesting we add a new feature? So for I can get involved in this, but I don't have all the context. So trying to get something in 130 with my involvement might be challenging. So especially I've got all these PRR trips to review in the next day. So so just like speaking for myself, if you need my help, it's going to be challenging to do anything in 130, especially if sounds like you're saying, because I'm not as familiar with the user space one either, user namespaces, like if we're trying to add API and go to beta, like add feature discovery to that and go to beta, that sounds like risky to me. Like,
so I think the feature discovery, John, is at the CRI level, not at the API level.
Okay.
So what we are thinking is like this particular CAP has a good solution for feature discovery at the between the kubelet and the runtime. So even if RRO itself doesn't make it, maybe that piece of it is probably applicable to the user NS, where there's an outstanding question on the PRR.
Okay. I'll try to dive into it today.
Okay, thanks. Just poke me. I'm happy to chat about it more.
Okay, cool. Thank you.
Thanks.
Okay, Jonathan just. Oh, Peter, do you want to wrap up? Or?
No, that's it.
Okay. Jonathan joined, and we will go with next topic from him.
Yeah, hey everyone. I opened a question in the SIG Node channel yesterday. It was mainly around, so just for context, I am from the Carpenter team, which is a sub-project of the of SIG Autoscaling. And one thing that we have been discussing right now, so we're currently thinking about basically promoting our APIs to V1 stable. And with that, we're kind of reconsidering a lot of the existing labels that we've written inside of Carpenter. We have a few labels that exist today. Like, so basically, we're using a lot of the same like node label selection logic that you can use with like node affinity for telling, either pods or nodes, like I can schedule on this particular node. And with that, we have a few custom labels that we've written inside of Carpenter. One of them is this carpenter.sh/capacity type, which effectively describes whether the node that Carpenter has launched at the cloud provider side is either a spot node or an on-demand node, and potentially we might extend that to other capacity types moving forward. And then we also have labels that are specific to cloud providers today, like this instance CPU and instance memory requirement, which we basically propagate the number of the number of CPUs from an instance onto a label, as well as we'll propagate the number of bytes for the memory onto a label as well. And what that, at least for the first one, basically what capacity type would allow you to do is to say, like, I have an application that tolerates spot interruptions, so I'd like to schedule on a particular capacity type. I can actually, or I can't tolerate spot interruptions. I can't tolerate like getting reclaimed. I need an on-demand instance. And so for cloud providers that have spot markets, you can basically say like, I am or am not flexible to this kind of reclaim logic. And based on that, you set a node affinity for that kind of thing. And then for instance CPU and instance memory, what we've seen is that customers are able to set greater than less than requirements node affinity that allow them to do some kind of interesting things. One of them being like, if you're trying to schedule a pod with a certain set of CPU requests, but you don't want to set limits on that particular pod. And you want to say, I want this pod to sit on a node that like I can burst into higher levels of CPU. Then I can say like, give me request one CPU, but also node affinity instance CPU greater than like 5 or something like that. So give me an instance that it has greater than 5 CPUs, but I am going to only have a single CPU. So I can know that potentially I can like burst into that additional CPU that sits on that node. So with those use cases in mind, I just kind of had like a general question about, we thought that these labels might potentially be relevant in like a greater Kubernetes upstream context. I think capacity type probably has the strongest argument. Some of the other like resource-based labels are kind of interesting and potentially also just generally applicable. Like minimally, we created like Carpenter supported with AWS and Azure today. And we created those instance like resource style labels with just AWS, but we're planning on pushing them at least minimally to like the neutral project because it seems to be generally applicable across other cloud providers. But there's kind of another question, which is, do these labels become relevant more generally? Like, are they relevant as like a node.kubernetes.io style label or a kubernetes.io style label? So I'm kind of curious, like, one, if anyone has any additional thoughts on that, and if that was something we were like considering pursuing, like what that process would look like, or if there's considerations we should make as we're thinking about like if this is something we should do upstream.
Jonathan, I had a quick question. Was it explored if the individual cloud provider plugins could apply these labels for their supporting infra? And then maybe my last question was like, I'm assuming you're not advocating for the kubelet to apply these labels?
Yeah, so I think the cloud provider could apply that. I guess I'm not necessarily questioning like who is responsible for like I think realistically it could be any component that adds these labels to the node. Like sure, it could be the cloud provider, like the CCM style component. I think the question that I have more is just from like an interface perspective, if we've got the sprawl of you know, my like controller implements, like capacity type is probably the easiest example. Like capacity type is a pretty, I guess, consistent thing that we've seen across like just some of the larger cloud providers, like spot and on-demand capacity, like spot markets is pretty common. And so, yeah, I think the cloud provider could apply the label. I think it's a question of if there's multiple controllers that eventually end up reasoning about these concepts, and there's kind of the sprawl and the community around, like I'm labeling it with my Carpenter.h capacity type label, and then something else is labeling it with a different capacity type label. Like, is this something that we should start to think about, like consolidating into a single like known API, regardless of what component adds it?
Yeah, I think capacity type probably makes sense. I mean, I don't see a clear security issue for the node advertising that it's be spot or on demand. I think standardizing as a project on that sounds good. I had just assumed that if you want the label to kind of be universally available, having the cloud provider plugins be the source of truth for that label is probably the best approach. But maybe others can give their perspective.
So I think that for something like spot instance or something that does make sense to me. I'm worried about things like instance memory, instance CPU. We have other efforts talking about those being mutable. Like, and there's like, as we look at things like what we're trying to do in DRA, there's other kinds of resources. There's extended resources. Like, where's the limit on what we model in labels, as opposed to creating an API for it? Like that, if you need to do selection in a node label selector, like type of level, you can propagate up to labels, but I don't want to build a whole model in a bunch of labels. That's, I guess, my concern. But whereas certain things that are definitely at node level, like spot versus versus not, like probably make sense. But I know Jonathan, we probably need to sync up on the stuff that Patrick and Kevin and Tim and I all been talking about on the DRA stuff. Like I think I see like just kind of coming in a little bit fresh in Node. Like there's a ton of efforts going on, like, and a lot of them are parallel. And I'm hoping we can try and like rationalize across a number of those efforts. So I just want to, I don't know if we'll be able to, but hopefully we will. Around resource management in particular is what I'm looking at. That I see a lot of different efforts there, and I think we should sync up probably on that. But that's my 2 cents anyway.
Would you say you're open to capacity type being a field on the node status resource, maybe, rather than a label?
Yeah, I mean, maybe actually there I don't mind the capacity type. I don't actually. By what you mean by that is spot versus not. That kind of makes sense as a label to me because it's kind of categorical for a whole node. And like the things I'm looking at are in the link to Slack. It's got like instance memory and instance CPU applied as labels. What about all the extended resources? What about every vendor type of resource? Like that it just seems like a slippery slope there.
Yeah, I agree with that.
Yeah.
That's why I was just curious if capacity type, just as a resource concept on the node object itself, maybe Jonathan, what would be your
Would you
thought
schedule
with that?
if it's like not a label on the node?
I mean, I share the concern that like propagating all node resources to be node labels to then drive selection criteria if the things that are on that node may or may not be mutable in the future. And whoever has node labeling powers can then maybe do a number of unintended things. Like I can see all the concerns that might go with overloading labeling. But if the idea was like, as a project, we don't have a place to advertise the nature of this node being spot or on demand, I could see an argument that could be in the node API, but I still probably would preference it to come from the cloud provider plugin rather than proliferate too many writers for this information.
Just for my own clarity, if it's in the cloud provider plugin, is it still, just from like an interface perspective, does that still exist potentially within like, well, I guess the cloud provider plugin also propagates the instance type, right? So like node.kubernetes.io/capacity type is still up for grabs. It's like an interface label key if it's advertised by the cloud controller manager, for instance.
Yeah, there's a very restricted set of labels that the kubelet can self-apply, and I really wouldn't want to open that to include these versus labels that other components can apply about the node based on their understanding of like the cloud inventory. And so capacity type is, to me, one of those things that like the cloud provider plugin could do in the same way that I think the existing CCM components go and populate like a failure domain.
Yeah, I mean, I agree. So from just like a fundamental perspective, I think capacity type has like pretty strong use cases. Like I will say that from like Carpenter's project perspective, like we're using these same labels for constraining like our instance type selection logic. So like instance CPU and instance memory make more sense in that context because you can say like, give me an instance type that is greater than this size. It's a little bit maybe more tenuous when you talk about pod application scheduling, where you're saying, give me schedule me to something that is of this size. Particularly when it comes to memory, I don't know that it makes a ton of sense. Anything that's burstable is probably the only real use case I can think of for doing like an instance or like some sort of scheduling logic for resource. Maybe there's other mechanisms to do that.
Yeah, I mean, I think we're working on some mechanisms in the 1/3, in the stuff we're doing, a more general purpose mechanism for constraining scheduling in more ways than we can do today, but it's obviously all up in the air. And it ties back to autoscaling, right? And I think Carpenter will be something that wants to use the data that's going to get published out of that process. So we should, like I said, sync up. But so that's my point of view on that. Like I think capacity type makes sense, but general purpose wise, like project wise, I don't think we want to encourage details of the node internals being published into the labels, really.
Yeah, I think that's a reasonable stance to take. Just so from the perspective of capacity type, like if I was interested in like proposing that as an upstream label that CCM and other cloud provider plugins could use, is there like what's a good process for proposing that change?
I remember we've been talking about some registry for all those names, but I don't know if this project moved forward.
Trying to think historically how we handled this, Jonathan. Like it's a perfectly reasonable question. Like I'd want to go through and just look at any discussion that happened around the node restriction admission plugin, or I think the most recent node label that I can think through that had corresponding discussion was the OS label that got propagated up. So either I would have to go and refresh my memory on how we best got that to a conclusion, or you could sleuth that in the interim, and we can typically just follow that playbook, and that was done there.
Okay.
I don't think it's too I mean, probably at best we'd want like a little bit of a very short cap describing the label probably, and then speak to who can set it, who can't set it, and if it's reconciled.
Got it. Okay. Sounds good. Thank you.
Thank you. Unfortunately, we're out of time and we still had a couple topics left. For reviewers and approvers, there are requests to look at some things. So please take a look at the links in the agenda document. And if something will be left over, we will discuss it next week. Thank you, everybody. Bye-bye.
Bye.